Hello everyone, welcome to the second video of machine dynamics based on topic single degree of freedom systems of free vibration. In today's video we are going to see one problem based on logarithmic decrement. So let us read the statement for that problem. A body of mass 5 kg is supported on a spring of stiffness 1960 Newton per meter and has a dashpot connected to it, which produces a resistance of 1.96 Newton at a velocity of 1 meter per second. In what ratio will be amplitude of vibration be reduced after 5 cycles? So this is the statement. Let us solve this problem by using a whiteboard. So first of all we'll write down the given for that problem and then we'll solve that problem. So same problem is mentioned on the whiteboard and let us find out first given a body of mass 5 kg. So mass is given here, m is equal to 5 kg, is supported on a spring of stiffness 1960 Newton per meter. So spring stiffness is given, so we usually used letter K for spring stiffness. So K is equal to 1960 Newton per meter and has a dashpot connected to it, which produces a resistance of 1.96 Newton. So force resistance is given, F is equal to 1.96 Newton and at a velocity of 1 meter per second. So velocity is also given, so V is equal to 1 meter per second. So what we need to find out here, in what ratio will be the amplitude of vibration be reduced after 5 cycles. So number of cycles are given 5 and after 5 cycles what will be the ratio of amplitude, that is x0 by x5, that we have to find out. So how to solve this problem? So first of all we should know the concept of logarithmic decrement. By using that logarithmic decrement formula we can find out this ratio of amplitude problem. So we can find out this ratio of amplitude, that is x0 by x5. So what is that formula of logarithmic decrement? That is delta is equal to 1 by n log to the base c x0 by xn. So this is the formula by which we can find out. So here number of cycles are given 5 log to the base c, x0 is the initial amplitude and x5 is the amplitude at 5th cycle. So x0 by x5 we need to find out. So for finding out this we should know the value of logarithmic decrement. So there is another formula for logarithmic decrement, that is delta is equal to 2 pi zeta upon square root of 1 minus zeta square. By using this formula we can find out logarithmic decrement. But for finding out this logarithmic decrement, that is a delta, we should know the value of zeta. So what is zeta? Zeta is c by cc, but in the problem statement there is no c and cc, so we should find out for c and cc. So for cc, what is the formula? 2 into m into omega n. Omega n is your angular velocity that we need to find out, so that we can find out the cc value. Then again c is the damping coefficient that can be find out by using the given values, that is force resistance and velocity. So c is equal to f by v, so that we can find out damping coefficient. So for finding out the angular velocity omega n, we can use the formula, that is square root of k by m. So let us find out first that omega n. So formula is square root of k by m. K is given, that is 1960 and m is 5 kg. So omega n will be 19.8 radian per second. After finding out this omega n, we can find out we can go for c, that is force upon velocity. Force is 1.96, velocity is 1, and so that we can find out damping coefficient, that is equal to 1.96 Newton second per meter. Then circular damping coefficient, how to find out that? Actually it is not circular, it is a critical damping coefficient. So it is a critical damping coefficient. Critical damping coefficient. So for finding out this critical damping coefficient, Cc is equal to 2 into m into omega n. So just replace the m value. M is equal to 5 kg and omega n is 19.8, so that we can put here, and we'll get the value of Cc, that is 198. After finding out this, we can use now both C and Cc to find out damping factor. So zeta is equal to C by Cc, and we will get the zeta is 9.89 into 10 raised to minus 3. For finding out this logarithmic decrement now, delta is equal to 2 pi zeta upon square root of 1 minus zeta square. Put the value of zeta, and by putting the value we'll get delta is equal to 0.0621. So this is our logarithmic decrement value that we require to find out the ratio of amplitude. So delta is equal to 0.0621 equal to 1 by 5 log to the base e x0 by x5. So by simplifying this, we'll get x0 by x5 is equal to e raised to 0.3105, and that value is 1.364. So in this way we can find out the ratio, that is x0 by x5, that comes around 1.364. Thank you.